Tablesaw Safety, and I'm just going to do a PowerPoint. Then after I've talked about that, Raleigh is going to talk about bandsaw, about safe setups on the bandsaw. He's got a presentation, and finally Steve will take us over to the joiner, and we'll do that. So, Tablesaw Safety. You just have to bear with me here. I gotta click this thing from here. We have 2 saw stops here, and that was a decision we made not to have anything other than saw stop. And this is an example of the saw stop cartridge firing. I don't know if everybody's seen that. It hangs on the wall over there. Should I pass it around, or everybody's seen it probably? Take a look at it afterwards if you want to. So that, the saw stop provides protection from blade injuries. So if you get your fingers in the blade or whatever, it's going to protect you from that. But it doesn't really protect you from kickback or other things. So I'm going to focus tonight more on kickback and riding knives and that type of thing. Wet metal or wet wood can also fire that cartridge. And if you look on the, let me just get this up here. So on the LEDs on the saw stop, the right LED is red. If you touch the blade with it on, that red LED will come on. Or if you put a piece of metal. So that's a good way if you want to test something before you cut, do that. You can also bypass that with the key. The key is on there. You turn the key, wait for it to blink, turn the saw on while you're holding the key, and then release it and wait for the blink again, and then all the safeties are bypassed. So if you've got something to cut that you're in doubt about, and if you've got something and you want to cut it at open shop here, ask for help on that. Because the cartridges cost about $100 and the blades cost, whatever the blade costs, anywhere from $50 to over $100 easily. And so, like I said, that technology doesn't really provide kickback protection. I was going to play this video that we shot with Mike firing the saw stop, but the audio isn't working on this setup, so I'm going to skip it. If anybody wants to see it, we can do it later. I can show it to you just offline. Kickback is what happens when the material that you're cutting comes back at you. It's slung towards you by the saw blade, and the circumference of that 10-inch blade, 31.4 inches, translates to a speed of like 120 miles an hour. So in 3 or 4 milliseconds, that can happen. So there's no time. I think the only thing that you can see with kickback that seems like it's in slow motion is if a piece of plywood or sheet goods roll up onto the top of the blade, and just the first second that they're moving towards you appears to be in slow motion, but that changes real quickly. And I've seen that, I've done that. I've seen that happen before we had saw stops or anything. Had a piece of sheet goods climb up the back of the saw and go like a frisbee back towards you. So you want to watch out. If in a perfect world, if you have a good blade and it's clean and sharp and the saw plate is aligned perfectly and material is well behaved, it doesn't have there's not reaction wood or anything, nothing happens. I mean, it's just smooth, and that usually, hopefully is the way things go, but they don't. Kickback is caused by material pinching as it exits the blade. So if you look up at the top of the blade here, you see the riving knife. Without a riving knife, which we'll talk a little bit more about, wood will pinch together or push apart as it goes through there, depending if the wood is case hardened or depending on the moisture content, and that will grab the back of the blade. And remember, the back of that blade that's the part of it that's coming back at you. So that's the danger zone. As soon as you get your material that you're cutting past the midpoint of the blade, you're starting to get into the danger zone. Because the torque of the blade will, I mean, it will start to feel like it picks up the piece. I'm sure you've all felt that, where, you know, it kind of lifts a little bit, chatters. So the material can get, can climb up the back of the blade like we talked about, and it can also be trapped between the blade and the fence, and that can be, usually is an alignment problem. The saws here, we haven't really done a full alignment for a while, but we do try to do that, and you want to have that, you know, you want to be dead even. You don't want to be pushing a cut into, you know, with the blade wider, you know, with your cut wider at the front of the blade than at the back of the blade, it isn't going to go well. So that's mostly where that comes from. The riving knife has been required on saws sold here since 2008, and it's a wonderful thing. So it sits behind the blade, and on new saws it rises and lowers with the blade, and it does several things. I mean, it keeps wood apart, you know, keeps that wood, anything that would pinch, it keeps it apart. It doesn't allow anything to get on top of the teeth in the back of the blade, so it can be flung towards you. So it's an awesome thing. The riving knife is sized to the kerf of the blade, and I have made the mistake myself of putting not on the saw stops, but a thin kerf blade on a table saw that's got a riving knife, but the riving knife is the wrong size, you know, so you don't want to do that. And I think we don't have any thin kerf blades here. I think originally SawStop didn't recommend using thin kerf blades.
They still don't.
I have heard that you can get a thin kerf riving knife, but I don't know. I have one for a Powermatic saw that I have. So we talked about pinching material, riding up the back of the blade. If you don't have a riving knife, there's aftermarket materials. This is Micro Jig, I think. They make that little, you can make a throat plate with these little things that you plug in and you drill. They've got a jig that you drill those holes with and set up. And that does work. I've actually used those on an older saw that I had. And you can also put a dowel in back of the blade or anything like that. So if you don't have one, so just in general, we want to keep our fingers 3 inches away from the turning blade. So use push sticks, feather boards, hold downs. You want to be positioned to the, on the left side over here of the blade. I've heard that the area, the area between the saw blade and the fence called kickback alley. So you don't want to be anywhere in line of that. You want to stand to the left. Also, like Tim was talking about in the shop when there's other people around, you want to check in back of you and be sure that there's nobody standing in back that would be impacted by kickback, or be aware of what's in back of you. So it's a dangerous spot. So in cross-cutting, I guess one other point is cross-cutting. If you're running repetitive cross-cuts of material the same length, don't put it on the miter gauge and run it against the saw fence to get your length. Clamp a stop block to the fence, use that, and then move past that, and that should be in front of where the blade starts cutting. So we don't get into twisting anything. Yeah, George?
What if you're left-handed? Could you put the fence on the other side of the blade?
You could, yeah.
And stay to the right?
Well, yeah, you just don't want to be between, the area between the fence and the saw blade is the danger area.
Okay.
Yeah, that's where things can get trapped.
I understand.
If you're, I don't really have it on here. Oh, like a mitered rip. If you're doing a mitered rip, a long rip like that, don't rip with the blade tilted towards the fence and the material riding against the fence for the width of your cut, because then you're just setting up almost a sure thing. You want to move you want to move to the other side. So the blade is tilted away from the fence and the cutoff can drop off, not get trapped and project backwards. The blade should be set, close to just an 1/8 or 1/4 inch above the material that you're cutting. So then, with the saw stops, it's not as big a deal, but with the older saws, if you get an 1/8 inch saw cut, it's not as bad as the full finger cut. Yeah. Right. Use a crosscut sled. We don't have a actual crosscut sled. We've got one for cutting miters, but I think that's something that we have here, because that's the safest way to do crosscuts, I think, that your material is on a sled that's pushing through the blade, and there's very little danger doing that. Come on. Oh, sorry, I'm on the wrong screen. Okay, so we've got some test questions. I pulled these. So we've got on every piece of equipment here, we've got an information sheet, and we've got a test that goes with that the information sheet covers everything. I just pulled 5 questions off of the table saw. So if any of you have taken classes, you've seen the information sheets. We hand those out at the beginning of the class that cover any of the equipment we're using. So when operating a table saw, you should stand B. Right, good. That is correct. And cross-cutting requires A, B, C, or D. Anybody? D is the correct answer. And a riving knife or splitter is used if you're cutting tapers, potatoes, cross-cutting, ripping. What do we think? Do I hear an E?
Yeah.
E is the correct answer. The only place not to use it is if you're cutting dado. We don't have a riving knife as wide as the dado blade. So. And then how high above the workpiece should it be set? As high as it'll go, or C? C is the correct answer. All right, everybody has passed the test. And that's it. That's the